All right, here's another video where we want to maximize an area. And let's remember what our steps are for optimizing, which is maximizing or minimizing a problem with pre-calculus. Number one, draw the picture and label it. So what we have is we have a rectangular shape and it's got a semicircle on top. So that's what we have right here. This is a rectangle and then a semicircle on top. We have 100 feet to enclose it. So all the way around is 100 feet. And what dimensions give the maximum area for the whole figure? So first we need to label it. Of course, it's got a length and a width. So let's call it L and W. And it's also got a radius because you've got a semicircle. And we're done with step one. Step two, what's the focus of the question? And remember, that's what you want to minimize or maximize. So in this problem, we want to maximize the area. And it's the whole area. So when we get that formula, we end up with a rectangle, L times W. And then this is half of a circle, 1/2 pi r squared, the semicircle. And we're done with step two. We have a formula for our focus. Now you don't have to do this now, but this is a problem. We've got three variables. We've got L, we've got W, we've got R. And while we can't quickly fix the L and W, we are going to, but we can't do it really quickly. We can actually make the R disappear, because if I draw the R from the middle out to the right-hand edge, parallel to the bottom, that's actually 1/2 of L. So I can actually substitute for R and write 1/2 L, and it simplifies down to this formula, which now we still have two variables, but 2 is better than 3. And we can go to step 3, which tells us we actually do need to find a constraint to get this W or the L out of there. And that's going to come from this 100 feet, something else that you're told. Remember, that's the full outside. So you've got 1L, right? 1L, you've got a right-hand W and a left-hand W, so 2 W's, and then half of a circumference, 1/2 2 pi r. And of course, remember, R is 1/2 L, the 2's cancel. And we end up with this formula. That's the constraint. And I'm going to go ahead and round the numbers to 4 decimal places. These are pretty hard problems, especially in pre-calculus. And while it's nice for us to be able to do them exactly, just for right now, we're going to just round things, help us out a little bit. So 1/2 pi plus 1 is 2.5798. And then let's solve for either L or W. I think I'll solve for W because it's nicer to divide by 2. And I end up with this lovely formula here. And when I do that and simplify, I end up with a nice formula, a quadratic that only has one variable, which is what we're going for. As a side note, just quickly, you don't have to look at this graphically, but it is nice to know. We're looking for this vertex right here. If I graph that formula, right, area is on the vertical axis, L is on the horizontal axis, and we're looking for that point, and we're looking for a specific L that gives a maximum area. Just kind of looking for the maximum area. It looks like it's about 700. We don't know for sure, and actually that's not even the question. The question is about what are the dimensions, but if we were asked about the max area, it looks like it's around 700. Okay, back to our steps. We have a formula for finding the vertex, or finding where the vertex is, and we do our negative b over 2a. A is this number here, is a negative 0.89. B is 50, plug it in, we get about 28.005, which, by the way, if we go back to the graph, right, it looks like that it should be about 28. And that's the length that we need. And the question is, what dimensions of the rectangle give the maximum area? We really just need the length and the width, because remember, the radius is defined by the length. And don't forget, we had this formula, I have it up in the right-hand corner. We found that earlier, so we just have to plug that in. And we end up with W is about 14. And those are the dimensions. And we're done with the problem.